Okay, so slope-intercept form where M represents slope and B represents the y-intercept. So how do we go about writing a equation for this line that we see here on the right? Well, what we want to do is we want to first identify the y-intercept because that's the easiest thing to do. So again, like I said, the y-intercept is where the line crosses the y-axis. The y-axis runs up and down. And so what we're looking for is where that y crosses, or where that line crosses that y, and it does so here at 4, right? So 4. So therefore, that means that our b, our y-intercept, is equal to 4. Okay? And now what we want to do is we want to identify our slope. So our slope is our m, so we want to identify our m to be able to plug that in. Well, the way that we identify our slope is we use the slope equation, which looks like m equals, hold on, 1 second, just want to make sure. Okay. y2 minus y1 equals x2 over x1, right? So that's our slope equation. So basically what we're going to do is we're going to identify 2 coordinates on the line. So I'll use this one. This one is -1 and 1, 2. So -1 and 2. And this one would be 0 and 4. Right? So those are our 2 points. And so now I want to go ahead and do, well, first let's identify, this is our x1 and our y1. This is our x2 and our y2. And now that we know that, we can plug that in. So y2 is 4. y1 is 2. x2 is 0. And x1 is -1. So that gives us 2 and 1. 2 and 2 over 1. So 2 divided by 1 is 2. And so that means that our m is 2. So our slope is 2. And our y-intercept is 4. Okay. So now that we have this information, we just go ahead and plug it in. So y equals m. What was our m? 2. X is our constant, so it always stays x. And then we plug in our y-intercept, which is b, which is 4. So we have y equals 2x plus 4. So that's how we find out, using a graph, how to plug this information into slope-intercept form and get an equation for our line. Okay. Does anyone have any questions about how I found b or how I found m? Any questions?
No, ma'am.
Okay. So we also have something that is known as point slope form. So we can either go ahead and create an equation in slope-intercept form, or we can create an equation in point slope form. So how do we go about, so this is the same graph that we saw earlier, but how do we use this equation to create the same equation that we arrived at previously? Okay. Well, let's identify what we have here, or what we need. M stays our slope. And then what we're going to insert here is an x1 and a y1. Well, this x and this y stay the same, okay? So again, I want to locate my slope. How did I do that? Well, I identify my points. So -1 and 2. And this one is 0 and 4. Again, you plug it into slope equation. So m equals y2 minus y1, x2 minus x1. And you just plug it in, right? That's the same thing we did here. We have the same slope because we have the same graph in this instance. So we know it's 2. But if you did start there, you would just do the same thing. Plug those into the graph, or into the equation. So our slope is 2. So m equals 2. And then what is our x1 and our y1? Well, like we solved in the other one, this was our x1 and our y1. This is our x2 and our y2. So x1 is equal to -1, and y1 is equal to 2. Okay? All right. So let me erase this just so I have space. Okay, so the first thing we're going to do is we're going to plug in our slope. Okay, well, what's next? Well, now I go ahead and plug in my x1 and my y1. So I'll start with my y1. So y minus 2 equals 2. Like that. Okay, now I need my x1. Like this. I want to see if I can simplify it all. This becomes a plus 1. Why? Well, because if I distributed this negative over here, this would become a positive. And so that's why I get 2x plus 1. Okay? So now I have it in point slope form. Right? And the way I got to point slope form was I identified my slope, which is this one right here. I identified my x1, which is this right here, and my y1, which was this one right here. So I just plug that into slope point form. Okay, and now I can go ahead and simplify. So let me distribute this 2. So 2x plus 2 equals y minus 2. Okay, let me isolate my y. So I'll add 2 on both sides, add 2. So that becomes y equals 2x plus 4, okay? Which was the same thing I got up here. Y equals 2x plus 4, y equals 2x plus 4. So basically, whenever I'm creating a linear equation for a graph on a line, I can use my slope intercept form, or I can use my point slope form. Okay, whatever my preference is, either way, I will arrive at the same equation. Okay, does anyone have any questions how I found my slope here, how I found my x and y, or how I even simplified to get to y equals to x plus 4? Questions?
No, ma'am.
Okay. So what about if I'm given something like this? Well, here I'm not given an exact graph, but I am given some information. And so this example says a line has a x-intercept of -9, and a y-intercept of 4. What is the equation of the line? Right? So this is the information I'm given. I'm not given an exact graph, but I am given some information. And that is that my x-intercept is -9. So basically that gives me the coordinates -9 and 0. So my x-intercept, let's say I had a graph, just to explain it better. Let's say I had a graph right here. Okay. So my x-intercept would be where my line passes my x-axis, right? And so my x-intercept always contains a y that is 0. So we would have -9, 0. Why is my y always 0? Well, because if it passes the x-axis right here, then that is when y would be 0. So whenever I have my x-intercept, my y is always going to be 0. On the other hand, whenever I have a y-intercept like I do here, it would be 0 and 4. So my x would be 0. And why is that? Well, let me show you. Say that it was right here, 0 and 4. Well, again, if I had a line that passed through there, oops, that's not what I wanted to do. My x would always be 0 in that instance because it would fall right here where x is 0. Okay? So that's how I know to get -9 and 0 and 0 and 4. So my x-intercept is -9, so -9 and 0. And my y-intercept is 4, so 0 and 4. Okay. So first thing I want to do is find the coordinates of the intercepts like I did right there, right? So I have -9 and 0, and 0 and 4. Okay, now what I want to do is go ahead and calculate the slope, because if I want to create an equation, I know that whether I'm creating a slope-intercept form equation or a point-intercept form equation, what I always need is a slope. I need to identify a slope. So I'm going to plug this in into my slope form, my slope equation. So that would look like 4, 0, oops, 0, -9. Okay, and how did I get these? We'll say this is x1 and y1, and say this is x2 and y2. And so I just plug those in. Okay, now I can go ahead and subtract across. So 4 minus 0 is 4, and 0 minus -9 is 9. And so my slope is 4/9, right? Because I can't simplify that any further. So I have my slope. M is equal to 4, -9. So now I want to identify my b, or my y-intercept. And I'm given my y-intercept here already as 4. So that's super easy. My b is 4, right? B is y-intercept. Y-intercept is 4. Now I write the equation. Okay, so because I have my b and my m, the easiest one I could use is my slope-intercept form. So that is y equals, what is my m? 4/9. X plus, what is my b? 4. And so that is the equation for that line that would be created when I have an x-intercept of -9 and a y-intercept of 4. Okay, and if we weren't already given the y-intercept, well, then what we would go ahead and do is use the point slope form to find the line. So an example of that. Say I didn't already know my b. So I would do y1. Y1 is 0 minus mx. No, m, which is 4/9. X minus x1, -9. I would simplify that. The way I would simplify, I would put this in, see what that is equal to, add 0 on both sides. Either way, at the end, I would arrive at the same equation. Okay, so there are instances when it is smarter to use your slope-intercept form, like in this instance. And there are instances in when you may have to use your point slope form. So the instances in which it's best to use your slope-intercept form is going to be when you already have your y-intercept. When you're not locating your y-intercept and you're already given it, that's probably the best instance to use your slope-intercept form, because you do need to include your y-intercept when doing that. But if you're not given it, then you might want to do point slope form. Okay. Any questions about this? How I solved this? And the next thing we're going to look at, again, this may be a huge review. We're going to look at parallel and perpendicular lines. So two lines are parallel if they have equal slopes. So say that I had a line. Well, I guess this is a good example. Okay, so lines are parallel when they never intersect, right? So parallel lines never intersect. So in this instance, the blue and the green line would be parallel. And the way we know those are parallel is because they have the same slope, right? We have 2x. They are the same. So because those slopes are equal to each other, m1 is equal to m2. 2x is equal to 2x. Because those slopes are equal to each other, we know we have a pair of parallel lines. But what about perpendicular lines? Well, perpendicular lines, the slopes of perpendicular lines are negative reciprocals of each other. And what are perpendicular lines? Perpendicular lines are two lines that intersect each other at right angles. And in this instance, the blue and the purple lines are perpendicular. So this one and this one would be perpendicular. And the way we know that those are perpendicular to each other is because they are negative reciprocals of each other. And how do we identify a negative reciprocal? Well, the negative reciprocal is basically switching the fraction and then applying the opposite sign, or applying the opposite side sign and then flipping the fraction. So for example, here we have 2 as our slope of our y line, right? We have 2x, so 2 would be our slope. So that basically would look like 2 over 1, right? Because that would give us 2 divided by 1 is 2, right? 2 divided by 1 is 2. So 2 over 1 could also be a representation of our slope. So how do I find the negative reciprocal of that? Well, the first thing I want to do is flip my fraction. So I'm going to flip it. So it becomes 1 over 2. And then the next thing I do is negate it. So negative 1 over 2, or I change the sign. And so as you can see here, my slope of my perpendicular line is in fact negative 1 over 2. So that's how you would identify your negative reciprocal slope. Okay. Any questions about this? So parallel lines have equal slopes, 2x, 2x in this instance. And then perpendicular lines are 2 lines that have negative reciprocal slopes of each other. So let me just show you another example. Say that I had one line that had a slope of 5. Well, how would I find the slope of my other line? Well, 5 is the same thing as 5 over 1, because 5 divided by 1 is 5. And so if I want to find my negative reciprocal, first thing I'm going to do is I'm going to switch those and then change the sign, right? This is a positive 5, so I want to change it to a negative. So my slope of my perpendicular line would be negative 1 over 5 if I wanted a perpendicular line, okay? If I wanted to find what the slope of the parallel line, the line which is parallel to this, it would have to just be the same slope. So y also equals 5. Okay, any questions? Okay. All right. So say we are given something like this, and we're asked to find what is the equation of the line which is perpendicular to our original line. So this one says, write the equation of the line that passes through negative 5 over 5 and is perpendicular to the line, and we're given an equation for our original line right here, okay? Well, what we want first to do is to identify if we can put this equation that we're given into slope-intercept form, because that would make it easier for us, right? To identify what the slope is. Once we identify what the slope is, then we can go ahead and find the negative reciprocal. So 2x plus y plus 1 equals 0. Okay. So the way I want to do is I want to isolate my y. So how am I going to isolate my y? Negative 1. That gives me, or leaves me with 2x plus y equals negative 1. I still need to move my 2x, negative 2x. So that becomes y equals negative 2x minus 1, right? And so there I have my equation for my original line. So this is my equation for my original line. And what I'm being asked to do is to identify, now that I know this, the equation for the line which is perpendicular to my original line. Okay, well, how do I do that? Well, the first thing I can do with this information is I can find out what my negative reciprocal, or my slope of my perpendicular line is. So I start with the slope of negative, oops, not what I meant to do. I start with the slope of negative 2. So I want to take negative 2 and find the reciprocal. Okay, right? Okay, so again, I'm going to put a 1 on the bottom because negative 2 divided by 1 is still negative 2. And now I'm going to switch them. So 1 over negative 2, sorry. 1 over negative 2. Now I need to switch that sign. So instead of negative, I need a positive. And so it become 1 over 2, a positive 1 over 2. Okay, so now what I've identified is my slope of my perpendicular line as 1 over 2. Okay, does anyone have any questions of how I got my slope for my perpendicular line as 1 over 2? Questions? Okay.
No, ma'am.
So now I have my new slope right there. Okay, now I'm going to erase this. Okay, so now I want to write an equation for it. Well, like I said before, if we had our y-intercept, then we could go ahead and automatically use slope-intercept form. But in this instance, we are not directly given our y-intercept, so we have to go ahead and find it. And the way we find it is we're going to use our point-slope form, which again looks like this, y equals y1, like this, right? And so do we have a point that we can plug in here? Yes, we are given exactly 1 point. And so that's the point we're going to plug in. So y minus, what's my y1? 5. What was my m? Well, I have it right here. X, what is my x1? Negative 5. Okay, now I can go ahead and simplify this. Starting with this gives me a positive 5, so x plus 5 equals y minus 5. Okay, now I'm going to distribute my negative. And so that gives me, not my negative, my fraction. X plus, so y minus 5 equals, so here I am right here. And now I'm going to go ahead and add 5 to both sides to isolate my y. And I'll write it up here so we can see it a little easier. So y equals 1 over 2x and so this is where I get right here. Oops. So that is my resulting equation. So what did we do here? Okay, so first thing we did was we looked at the equation of our original line. Hold on, sorry, I'm all over the place. Okay, first thing we did, we looked for the equation of our original line right here. Okay, the next thing we did is we identified what our slope of our new line would be given that those two lines are perpendicular to each other. So we have to identify the negative reciprocal. Once we identify the negative reciprocal, we need to determine, can we put our information into slope-intercept form? Or can we put our equation into point-slope form, right? And we identified that we need to put it in point-slope form because we're not given our y-intercept. If we are given our y-intercept, then we can easily just put it in slope-intercept, but because we're not, we're going to put it in point-slope form. And so putting in point-slope form, we need to identify our slope, which we already did, and we need to have access to the coordinates of 1 point, which was this one right here. And so we plugged that in, then we simplified, and then we arrived at our resulting equation for our perpendicular line. Okay? Is there any questions? Questions, concerns? Okay. And so lastly, we're going to look at one more example where we may be asked to write an equation for a specific line. So here it says, an online bookstore is having a sale. All books are being sold for one low price. Kendra ordered 3 books and paid $23.50. Marvin ordered 5 books and paid $33.50. Ling ordered 2 books and paid $18. Wait, Ling ordered 2 books and paid $18.50. What is the total cost for 15 books? So basically what we're trying to do is we're trying to identify the relationship between books and how much they paid. So we want to identify how much is each book, okay? And the way that we're going to do that is we're going to go ahead and identify two coordinates for things that represent how many books we paid and the price we paid, okay? And so here are my two coordinates. I'm going to use Kendra and Marvin. So when Kendra bought 3 books, she paid $23.50, right? That's basically what that coordinate is telling me. And when Marvin ordered 5 books, he paid $33.50. And so that's what that's telling me. So I want to identify two coordinates. Once I identify those two coordinates, what I'm able to do is identify my slope and identify whether or not I have a y-intercept. And if I don't have a y-intercept, then I just use one of these coordinates, put it in point slope form, and solve. So the first thing we're going to do is identify our slope, right? So if I want to write an equation which will help me identify the cost of each book, what I need to do is identify my slope. So m is equal to y2 minus y1 over x2 minus x1. So 33.50, 23.50, 5, and 3. And if you want to know where I got that information, again, this is my x1, my y1, my x2, and my y2. And so I just plug that into the slope form, or the slope equation, which gives me 10 over 2. 10 divided by 2 is 5, and so my slope is 5. So I know my slope is 5. Okay. Now, do I have a y-intercept? Well, no, I'm not told anything about how much the cost of 0 books is, right? Because for my y-intercept, it would have to be 0 and then whatever my y is. Well, I'm not told anything about that. So I want to identify my y-intercept. And the way I'm going to do that is I have one coordinate. Okay. And so what I can do is put that into point slope form. So y minus y1 equals mx minus x1. So I am given my m. My m is 5, so I can plug that in. And now I can plug in my 1 point. So here I see y1 is 32.5. I mean, 23.5. Okay. Oops, that's not what I meant to do. Oh, sorry. My mistake. 3. Because I need my x1. My x1 is this one right here. Okay. So now I have this. So now from there, I can go ahead and simplify. So distribute my 5. So 5x minus 15. Okay. Equals y minus 23. Okay. Now add 23.5 on both sides. Okay. And that gives me y is equal to 5x plus 8.5. Okay. So now I have this equation. So this equation would represent to me how I can identify what the cost of each book is. So now I want to go ahead and solve. And the way that I would solve is now I have this equation. And so what do I want to identify? Well, I want to identify what is the cost of 15 books. So I would just plug in 15. So equals 5. What is the cost of 15 books? So my x is 15. Okay, that gives me 75 plus 5. So my cost of 15 books is $83.50. Okay, so let's go over what we did here. The first thing we do is we identify two coordinates. Once we identify two coordinates, we put those coordinates into our slope equation and identify our slope. Okay, Then what we want to do is identify, do we have a y-intercept? If I have a y-intercept, then I use my slope-intercept form. But if I don't, then maybe I use my point-slope form. So I do not have a y-intercept, so I'm going to use point-slope form. So then we plug in everything into point-slope form, and then we arrive at this equation right here. And now we can use this equation to solve the problem, which is, what is the total cost of 15 books? So we plug in 15 and solve. Okay, any questions here? No? Okay, so that's basically the gist of what we're learning today. Like I said, today may have just been a review of what you saw in Algebra 1. Okay, so what did we learn? Well, we learned when we're writing a linear equation, we can either use slope-intercept form or we can use point-slope form. The big takeaway that we learned from this is that it's smarter to use slope-intercept form when we know the y-intercept. When we're given exactly what the y-intercept is. If we're not given specifically what the y-intercept is, then it's more logical for us to use point-slope form. Okay? And basically what you do is you substitute any known variables and solve. Okay? The next thing we looked at was the relationship between parallel lines and perpendicular lines. So parallel lines have equal slopes, so they are the same. And then perpendicular lines have negative reciprocal slopes. Again, how do we identify the negative reciprocal? We flip the fraction and then change the sign. Right? And that's how we find the negative reciprocal. Any questions about any of these two topics that we have here? Questions? Okay. Okay. So whenever we're asked to write an equation given 2 points, the first thing we want to do is find the slope. Choose one of the points to be our x1 and our y1, and then substitute those values in, and then simplify. Right? And so this is when we'd use the point-slope form. We use the point-slope form when we're not given our y-intercept. To write parallel and perpendicular lines, again, we want to identify the slope of our original line, and then find the slope of our parallel line, which would be the same, or our perpendicular line, which would be the negative reciprocal, and then plug it into our point-slope form. This is what we did today. And then lastly, if we want to write an equation to solve a word problem like we just did, we identify any ordered pairs, find the slope, choose one of the coordinate points to be our x1 and our y1, and then plug that into point-slope form. Okay? Any questions about what we did today? Questions, concerns? Okay, perfect. All right, if there's no other questions, you guys may log off and we'll work through some practice problems tomorrow. Okay? Bye, guys.